Hey all, so this is section 1.5 and it covers formulas. A formula is just an equation with more than one variable. These first couple of examples we're going to look at are going to be evaluating formulas. So given this formula, here's these values, figure out what that would equal. And then the rest of the section, which will be most of it, is again solving equations just like we've been doing in the last few sections. But this time there'll be more letters, more variables in the problem than just straight numbers. So for these first couple of evaluate problems, we have evaluate b squared minus 4ac, where a is negative 4, b is negative 7, and c is negative 8. So let's rewrite this. So, oops. B is negative 7, so we're going to want to be careful to put that negative 7 in parentheses, because we're saying negative 7 times negative 7. Careful not to write, if you write negative 7 squared, that's the negative of 7 times 7. That one would be negative 49. This one is negative 7 times negative 7, so it's going to be positive 49. So this is not what that means. And then we're going to go minus 4 times a is negative 4. And anytime you're substituting in, it's safe to put parentheses around that, and that will help you with what the sign should do. And then c is going to be negative 8. So negative 7 would be positive 49. And then that would be, let's see, we got 1, 2, 3 negative signs. So if we multiply 3 negatives together, it's going to be a negative. If there's only 2 negative signs, it would be a positive. And so 4 times 4 would be 16 times 8 would be 128. And then just finishing that up, saying 49 minus 128, and that would be 79. So that's a very basic, just evaluate the formula with these given values. This next one uses a couple of words in it. Use the conversion formula of this to find the Celsius temperature. So we're going to find C if the Fahrenheit temperature is 41 degrees. So we're putting in 41 for Fahrenheit and then using this formula to find Celsius and convert to Celsius. So we'll get that written out. C equals 5 times 41 minus 32 over 9. And let's see, so that would be 5 times 41 minus 32 would be a 9 right there, over 9. And I guess you could go 45 over 9 and divide. I'm just going to cancel those 9s since I can see that right there. And then that would be 5 Celsius. Okay, so now we're into the ones instead of evaluate, now we're solving for a given variable. So in this case, it wants me to solve this equation for b, and in other words, I want to get b by itself on one side of the equation. There is often more than one right way to do that. To me, the easiest one here, the b is in the denominator, and that is not helpful. I need this to be b equals, not 1 over b equals. So for me on this one, my first move would be to multiply both sides by b. And what that's going to do is get that b out of the denominator and then up into the numerator where I need it to be. So we'll cancel those. And that gets us to 2a equals hb. So now if I want to get b by itself, I would probably want to divide both sides by h. Seems like the plan since this is an h multiplying the b. H is canceled, so then 2a over h would equal b. Yeah, but you really don't want to do that the other way. You could divide both sides by 2a. Ugh, no, that would be horribly messy. And then you still have to get b out of the denominator. So this is really the path of least resistance, is to bring that b up out of there right away. This one we were solving for h, so that's right there. I would clear the fraction first, because I can't add or subtract that b right now because of the fraction bar. So let's do this, and we're going to multiply both sides by 2. So on this side I'm going to have 2a, those cancel, and then I have h plus b. And then let's, we want h by itself, so we're going to subtract the b on both sides. So minus b, that leaves h by its lonesome, and then we have 2a minus b on this side. For this next one, we're supposed to get x by itself, which is actually totally easy because it's x minus 3y. It'd be harder if we were solving for y. So we can just, add 3y to both sides. That got the x all by itself. And we could write it as 3y minus 7. We could also write it as negative 7 plus 3y. I guess that one looks a little bit nicer, but they're absolutely equivalent, so you could write that either way. Here we're solving for w. And this isn't a good example, I was just thinking to show if you're having a little bit of a hard time because of the extra letters and trying to see what to do. Sometimes if you think about what would I do if we're trying to solve for that w, what would I do if these were just numbers? So pretend for a second we had 10 equals 5 plus 4w, right? These are of the exact same shape. And so in this case, like we did in 1.3, even 1.2, we would subtract the 5 over and get 5 equals 4w, and then we would divide the 4 and get 5/4 equals w. It's the same thing over here. It's the same shape as this. It's just over here when we subtract, we can't combine terms like we could on this side. But it's still, I want to do my add or subtract first. So I'd subtract the 2v off of both sides. And that would get me p minus 2v equals 4w. And then we would, the same here where we divided the 4 on both sides, we'll do that right here. And so p minus 2v over 4 equals w. If you're having any thoughts about reducing that 2 and that 4, you could, but I don't recommend it. And the reason is the 4 doesn't reduce with the p, and then you're going to get separate denominators. You could also write this as p over 4 minus v over 2. Most people mess up and they don't do the 4 over here. They just cancel that out and call that 2. That's not right. So if it doesn't cancel in everywhere, I would just leave it in that form. But there's the correct form if you were thinking about canceling. And then this last one, I think that's the last one, yep. This last one is the exact same problem as this one. We're solving for t. There's something that's positive here, so I'm going to subtract it, and there's stuff that's multiplying, so I'm going to divide it. So if I subtract p from both sides of this, then we're going to have a minus p equals prt, and then p and r are both multiplying t, so I would want to divide both sides by pr. And that cancels, and then that would be it. Again, this is how I would leave the answer if you tried to reduce it, and I'm strongly suggesting don't. I'm not even sure the computer would take this version of it, but just if you're wondering what that would look like reduced, it would be a over pr minus essentially p over pr equals t, and then from there you can reduce the p's. So this denominator belongs to both terms. A over pr equals minus 1 over r, when you cancel those p's, equals t. Again, there's no reason to do all this. It is a perfectly fine answer right there. It doesn't need to be reduced, so that's the place to stop. But if you're curious, that would be the correct way to sort of semi-reduce that, but it's really not a good form of the answer. I think that is it for that section. Yeah, that's it. Okay, cool.